Okay, let's go ahead and do a video to explain this warm-up for Chapter 20. Okay, so if you have not already read the problem, here we go. You've got a report on healthcare in the U.S. that said that 28% of Americans have experienced times when they have not been able to afford medical care. All right, so keep in mind that this is a statement about the population of Americans, okay? So this would be where your population P is coming from. All right, so this would be the proportion of all Americans that say they cannot represent, that they can't do. So that's again for healthcare. For all Americans. Sorry, for all Americans. All right. Then there's a news organization that randomly sampled 801 Black Americans. So they took a subgroup of all Americans, and they had 38% of that subgroup report that there are bad times when, in the last year, when they had not been able to afford medical care. So does this indicate that this problem is more severe among Black Americans? So think about this. What you're doing is taking a statement about all Americans and seeing if you have evidence that the Black American subgroup is still having that same rate, or are they having a rate that is significantly higher? Okay, so that's what this is talking about. So when this says test an appropriate hypothesis and state your conclusion, make sure you do any necessary conditions and state the conclusion in context. So all of those things, that is our phantoms model. And I know you actually don't have a back in your packet that is blank, so somewhere if you did have blank paper, or if you could squeeze it in there on in this number 1's blank space, but here it is. All right. So what we are going to be doing is determining the proportion of, again, all Black Americans. So anytime you can reference the entire population. So the proportion of all Black Americans that experience times when they cannot afford health care. And so make sure that you use current tense, because we're making a statement about the current state of all Black Americans. If we put it in past tense, that kind of is implying we're talking about the sample that we took. We're taking a sample and then making the statement about the current state of all Black Americans. All right. And then the H is your hypothesis statement. So the null, of course, is that the proportion of Black Americans that say there are times when they cannot afford health care is at the same as the overall Americans. Okay, so that's what the null is saying. The subgroup is the same as the overall American group. And then the alternative is saying they think it's possible that the subgroup of the Black Americans is greater than the population proportion of 0.28. And then we're going to do our assumptions and conditions. Random was stated. For the independent, I'm sure it's very plausible that 801 Black Americans is less than 10% of all Black Americans. And large enough, you do your n times p and your n times 1 minus p. Make sure you are using the population p, which is 0.28, not p hat of 0.38. Okay? And so those are also meeting the conditions, so the normal model applies. And now we're going to name the test, which is a 1 proportion Z test. Now T is to get a test statistic, which our test statistic is getting a Z-score. So we're going to kind of lay out all the information. So we've got that the mean of the sampling distribution is 0.28. Our sample is the 0.38. Now, look at your standard deviation. Of course, it is following the formula. Notice inside here is 0.28 times 0.78, not the p hat. All right? right? It's the population P, since you have a population P. And so then our z-score, we're comparing our sample results to the population claim, dividing it by that standard deviation, and we get 6.28. So that's already, I'm thinking, whoa, that's way far out there. Okay, so I'm going to norm CDF to get that area from 6.29 to 99, and I get a very, very small number, so basically 0. So obtain a p-value. So my p-value is basically 0, which certainly is less than alpha. Again, if it does not give you an alpha, that is the default of 0.05. So, make a decision. I certainly have strong evidence to reject the null hypothesis. And so here's my conclusion. Since the p-value is less than alpha, and you can put we have evidence or we reject, you don't have to put have evidence, but you may have chosen to do that. I like to say we have evidence, not necessary. We do have evidence that to reject the null hypothesis, which is that proportion of Black Americans that experience times when they cannot afford health care is 0.28. So we are rejecting that. And if we reject that, then it's common to then go ahead and say, well, if you reject it, then what are you saying? Plus, before you finish out your conclusion, and I'm going to do this right now, before you finish that conclusion out, you need to go and read the question to make sure you answer specifically that question. And that specific question is, does this indicate that this problem is more severe among Black Americans? You have not completed your conclusion until you have answered that question. So don't go put a period and turn to the next problem until you answer that question, which is, there is evidence to suggest that, here it is exactly, the problem is more severe among Black Americans. All right? So it's critical that you have done all this work. Make sure you answer the question that they ask. So take that extra little look back at the paragraph and do that. All right, so we finished number 1. Now the second one is, was your test one tail upper, one tail lower, or two tailed? That's based off of your greater than, your less than, or your not equal to. So if it is one tail upper, that would have been a greater than alternative hypothesis. If it was one tail lower, it would have been a lower hypothesis. And if it was two tail, that would be your not equal to. Explain why you chose that kind of test. And it was because it was one tail upper because we are interested in if we find evidence that the problem is more severe among the subgroup of Black Americans. And then finally, here is the p-value. What is the p-value? Again, the p-value you got was 0. Okay, so the p-value you got was 0. Now, you need to remember the p-value definition is not your conclusion of your phantoms model. Your p-value definition is saying there's a 0% chance that you would have gotten the sample you got if the null hypothesis is true. Remember there's our little song. Do you remember when we used to sing? So the p-value is the probability. So basically there's a 0% chance of getting this sample or something more extreme. Okay, so there's a 0% chance that we would get this sample results, 31% of 801, or something more extreme. Okay, so that's the second part of the song. And then the last part, if the null is true. And so here I come and state if, and then here is the null hypothesis in context. So again, here is the p-value is the probability of getting this sample or something more extreme if the null is true. So that's the 3 subsections. All right, so that's all the warm-up.